Hello and welcome to today's webinar. My name is Tyler Reid. I'm the Manufacturing Application Manager here at GoEngineer. And in today's webinar, we are going over what I would consider sort of the three essentials for successful CNC programming. So in today's webinar, we're going to be covering some things that I view as essential for having a successful interaction with a CAM tool, CNC programming tool. Now, specifically, we're going to be talking about this in the context of SOLIDWORKS CAM and CAMWorks. And I'm going to give a real quick introduction into those tools before we jump into the software and talk about things that I view as being necessary and sort of unique to SOLIDWORKS CAM and CAMWorks. If you aren't familiar, SOLIDWORKS CAM is the OEM CAM solution now for SOLIDWORKS. SOLIDWORKS is a name I'm certain you have heard of. If you're in the design or engineering industry, you know SOLIDWORKS has become the industry standard for 3D CAD software. We have over 2 million users worldwide now. Along with being the global leader in this industry, it makes sense that they're also the leader in creating training and offering great user experience. SOLIDWORKS has a team of developers that are dedicated towards matching the UI to human behaviors. If a new user can't use this software on day one and use it effectively, then they're doing something wrong. And that's something they strongly believe in both their CAD tool and their CAM tool. Now, CAMWorks, if you aren't familiar with it, it's actually the original feature-based CAM. Feature-based CAM is a concept that has been around for quite a while. It's picked up a lot of steam over the past few years as some of the kind of 800-pound gorillas in the industry have started talking about it. But CAMWorks has been doing it since the mid-1990s. And for many years during that time, we were asked, why are you sticking with feature-based CAM? It's not as good as operation-based CAM. And maybe that was true, 20 plus years ago. But in today's day and age, it's been proven that feature-based CAM is more efficient than operation-based CAM. And you'll see a glimpse into what good, strong feature-based CAM looks like here in a minute. Now, another first, CAMWorks was also the very first SOLIDWORKS Gold partner. So SOLIDWORKS came out in 95, 96 or so, and their very first Gold partner was CAMWorks. Gold partners are approved, tested, third-party add-in tools. And so for the first 20 plus years of its existence, CAMWorks was always kind of a separate thing. It always ran inside SOLIDWORKS. It was never developed to run outside of SOLIDWORKS, but it was always a third party. Now, with the advent of SOLIDWORKS CAM, CAMWorks is part of the OEM SOLIDWORKS tool. So this is capitalizing on a very long-standing and healthy partnership between the two. If you've been using SOLIDWORKS for any amount of time, you've used CAMWorks technology without realizing it. And SOLIDWORKS CAM is just the next step in the evolution of this partnership. In the background, SOLIDWORKS CAM and CAMWorks are the exact same tool. It just depends on how much software you're using, what are your CAM needs. So now that that's out of the way, let's get to the meat and potatoes of this presentation here. What is required for a positive user experience or just great programming success when it comes to a CAM tool? Now, I kind of built this off of some polling that was done by CNC Cookbook. If you guys are familiar with that, I know a lot of you out there are. CNC Cookbook does this yearly polling, and they ask their users, what's important to you? Number one answer in the recent poll was, it has to be easy to use. And I broke easy to use down into a few distinct steps. Number one is it has to have a simple workflow. Basically, do this X number of steps and repeat it. If you can't boil it down to a few steps that you just repeat over and over, then it's not an easy to use software. So when it comes to SOLIDWORKS CAM or CAMWorks, these are your 3 steps you have to remember. We're going to create a setup, and a setup is a direction of cut. Then we're going to create a feature. What are we cutting from that direction? And then we're going to create an operation. How are we going to cut that? So what direction are we cutting from? What do we cut? And how do we cut it? So let's jump into the software and see what that looks like. Many of you watching here are SOLIDWORKS users, but if you aren't, Welcome to SOLIDWORKS. This is a SOLIDWORKS user interface. We have a part that was drawn in SOLIDWORKS. We have our feature tree over here on the left. This allows us to roll back in history and see how this part was drawn. It would allow us to make any edits or changes to dimensions if needed. It allows us to very quickly prototype and iterate our CAM program. Now we're inside SOLIDWORKS, but we have a couple extra tabs that are specific to the CAM programming. Now I said step number 1 is creating a setup, a direction of machining. So we're going to go ahead and do that. I want to cut one of these pockets. So I'm going to click on that face to set the direction. That's step number 1. Step number 2 was a feature. So now I'm going to create a feature. And in this case, it's a pocket. I'm going to use the faces of the model to define the upper and lower bounds. And I'm going to select something called a strategy. We're going to get back to that in a minute. In this case, I'm going to choose the rough finish strategy. That was step number 2. We have a feature. Step number 3 was an operation. How are we going to cut that feature? I'm going to do this the manual way. So we are going to add a rough mill. I want to rough this pocket out. I need to choose a tool. Let's maybe choose this 3/8 inch end mill. And then, of course, I have a lot of CAM data that I have to account for. I have to select some feeds and speeds. I'm going to have to specify my roughing pattern, my step over, my side allowance, my depths of cut. Everything sort of starts in a generic way. Now that we have a rough mill, I'm going to add a finish pass. We're going to finish these walls. Again, I'm going to manually choose a tool. Now I'm taking a guess. I don't really know the size of my pocket, and I don't know how that relates to the tool size. And again, of course, I have all of this CAM data to customize my NC planes, my rapid clearance plane, how I'm entering and exiting, my lead in and lead out. But now I have operations. So I have a direction of machining, I have a feature to cut, and I have some operations. The last thing to do is just apply the toolpath to the part. This workflow that I just did is the same workflow that you're probably familiar with an operation-based CAM tool, where everything's sort of manual. We have to choose what to cut. We have to choose our tools, the order of which can kind of go back and forth. But it's not a very smart process because I'm left with some tools that might not fit and some parameters that need some heavy customization. Now, the magic of CAMWorks and SOLIDWORKS CAM is that it will automate a lot of what we just talked about. But going back to the software needing to be easy to use, part of being easy to use is that it has this simple workflow and it doesn't force you into any certain type of workflow. So even though I just did it manually, we'll be able to do it automatically here in a bit. Now, speaking of automatic and intelligence, step number 2 for being easy to use is your CAM software has to be built on the right foundation. So what I mean by this is that the structure of the software should be set up to make you as the programmer successful. Think about it this way. We're cutting this, it looks like a piston. We're cutting this piston. And I imagine that the cylindricity of this piston is an important feature. It has to be as round as possible. Given the option, would you cut this on a mill or would you cut it on a lathe? Most likely you're going to cut it on a lathe, right? Because the lathe has the right foundation to create very accurately round parts. The mill can possibly do it, but it's not set up to perform that duty as well as a lathe. And this applies to a lot of things, but it applies to CAM software. It needs to be built on the right foundation. And what I mean by that is CAMWorks is feature-based. Feature-based CAM software turns the workflow around a little bit, and it has programmers identifying intuitive features. Holes, slots, bosses, pockets, perimeters. When it comes to milling, when it comes to turning, you have things like the OD and the ID, grooves, face. Intuitively, as a machinist or a programmer, you know what these are, and you kind of know how you would deal with them. If you know that, you can create them manually, or you can have actually the software create them for you. But the idea is that by front loading the software with a feature, you're feeding it a lot of information. And here's where the right foundation comes into play. In the background, SOLIDWORKS CAM and CAMWorks are controlled by this database. We call it the technology database. And this database is set up to learn from you how you machine your parts on your machines. It saves this info, it retains it, and it allows you to share it with the rest of your shop or your team. Now, this has been proven to be a faster way to program because we have our features at the beginning, they have all of this info, and rather than relying on our own brains, which I know we're all aging and our brains are working a little bit slower, rather than relying on our own memories to recall what had been done successfully in the past, we let the database do that for us. That means we're making fewer mistakes, we're reducing scrap and crashes, we're extending tool life, our machines are healthier. A lot of the kind of costs of creating parts goes down due to more efficient programming. Now, you might be saying, my software can do this. I have templates. And templates are similar to this. Templates are recipes that have been proven. But the difference here, as I'll show you, is that CAMWorks is built on this methodology to choose the template for you based on the features and the dimensions and the parameters of your parts. We'll get back to that. Now, continuing on this easy to use step. In order to be easy to use, the software has to be useful to a layman and a career programmer. More and more, we have people being asked to do more. They're being asked to play double duty. They're being asked to not only be programmers, but machinists and designers and engineers. And so software has to cater to everybody. And CAMWorks and SOLIDWORKS CAM does this better than any other program I've seen. And it has to do with the fact that it's been co-developed by the SOLIDWORKS programmers. And the SOLIDWORKS programmers know how non-machinists think. So it's been a great thing to have their input on the development. Now, the last thing here and easy to use is I have to ask people, really beg you, don't mistake simplicity for ease. Just because something is simple, that doesn't make it easy. Or making it simple is not the best way to make something easy. And what I mean by this is, take a look at a software that has very limited functionality. If it's a one-button program, or if it can't handle multi-axis, or it can't handle mill turn, of course it's going to be easier than something that can. But taking tools out of the software is not a great way to achieving this number one requirement in ease of use. Step number 2 to making a CAM program successful for you is it has to create smart toolpaths. So when you're programming by hand, or if you're programming with an operation-based tool, you're looking at the features and you're assessing, what size tool can I fit in that feature? Have I cut this feature in the past? What are the tolerances that I need to hit? What is the depth of the feature, and is that going to affect my tooling selection? How rigid is my machine, etc.? All of these are going to help you attack how to create good toolpaths. And as I mentioned before, templates are a proven way of handling this scenario a little bit more elegantly. A template typically would allow you to program a part, save it as a template, and then later, as a programmer, access it. But again, this relies on you to, 1, remember you made that template, and 2, it really is only halfway to the solution. The real solution is using all of this data and having the system choose a template for you. And that's what SOLIDWORKS CAM does. So let's go back to this part here. And we're going to create another feature. We're going to do this other pocket over here. Now in this scenario, I'm going to choose my rough finish strategy, but instead of manually adding a rough mill and a finish mill, I'm going to tell this generate an operation plan. And what generating an operation plan did was it went back into this database and it picked a tool, it picked feeds and speeds, it picked a depth of cut, it picked everything for me based on what I've done in the past. Okay, so the idea is that as I program parts, I save my work back to the database, and the database learns how I like to cut features on my machines to hit tolerances that work for me. Now, what does it look like to teach the database? Well, let's make a few changes here. So if I come into this rough mill, and let's change the pattern to something like offset roughing. And we're going to change the sidewall allowance to keep only 8 thousandths on the wall. And we'll specify a final cut of 5 thousandths. So we're going to see an extra pass in Z to finish the bottom of that pocket. And now on the contour mill, let's actually use a little bit smaller tool because the radius of my feature is a little bit tighter than the tool it's selected. So we're going to go into our tool library and we're going to add a 1/8 inch 4-flute carbide end mill. And I'm going to do a little bit more customization. You know, maybe I will specify a final cut on the wall of 5 thousandths. We'll do that in a single depth, and this final pass we'll do at 120% the speed. Okay, so that's changed a little bit. And now maybe I want to do one more thing to this pocket. You know, maybe I want to add a chamfer at the top here. So I'm going to quickly add a chamfer manually. If I know exactly what I want to do, I do have the option of doing that. All right, so we have a nice little chamfer there at the top. Now, if I like this and I feel like I'm going to use this in the future, I can save this back to the database. I'm essentially saving a smart template. So I'm going to give this a new name. It's going to be called Rough Finish Chamfer. And now that's going to be accessible to me on future parts. Now, to give you an example, we'll use it on this pocket. So this pocket that's next to it. We're going to create this feature. But this time, instead of choosing my rough finish strategy, I'm going to choose that RFC strategy that I just saved. And when I run it through the database, it's going to create my 3 tools, my rough mill, my finish pass with the 1/8 inch tool, and my countersink tool doing the chamfer. It chose that for me, and it will do that in the future if I ask it to. Now, I set that as a separate selectable strategy. I could have overridden the default strategy, but as I build this out, I can create very smart templates that are chosen for me. Now, I'm going to give you a peek into the database here in a minute, but let's step back to our PowerPoint just really briefly. So step number 3 to a successful program in CAM, a modern CAM program, is you have to have robust CAD tools. We see this more and more. There's a lot of different CAM softwares out there, and many of them are standalone software. They don't run inside SOLIDWORKS or another 3D CAD package. And those softwares have always struggled to offer the programmer good drawing tools. And you can imagine as we move towards this Industry 4.0 or digital thread concept where our PMI or our product manufacturing info is in the 3D CAD model, and there is an initiative to eliminate 2D drawings, being able to draw in your CAM tool is becoming more and more important. Not only is it more important, but it's just more efficient. We minimize errors. There's less room for interpretation, mistakes in looking at a drawing. And when we're programming on 3D models, the fact of the matter is, no matter how good your CAM tool is, sometimes we need sketches. Sometimes we need to draw surfaces to help with the programming. If machining to tolerances is required, which it almost always is, we need to be able to interpret those tolerances and allow the software to read those tolerances. And SOLIDWORKS CAM and CAMWorks is the only software out there that is looking at 3D PMI data and making machining suggestions for you based on tolerance windows. Also, digital setups, like you see here with the fairly complex tombstone, reduce expensive mistakes. Digital setups are going to reduce scrap. They're going to reduce crashes that result in broken tooling. They're going to reduce crashes that force you to call your technician and have them schedule a time to come out and check the alignment on your machine. And it allows us to do complex, more intuitive fixturing. And you don't have the opportunity to do digital setups like you see here without a strong CAD tool. And the reason why I stress this is because with SOLIDWORKS and CAM tools running inside SOLIDWORKS, you're literally sitting inside the industry-leading 3D CAD tool. So how would this affect programming a part like this? Well, here's a pretty good example on the back side here. We have this dome that most people would surface with a ball nose end mill. And then we have this emblem, our logo here, imprinted in the dome. Now, if I'm cutting this and I'm concerned about the aesthetics of what I cut, I'm probably going to want to cut this in 2 steps. I'm going to want to cut this dome, and then I'm going to want to cut this pocket. Now, if you don't have good surfacing tools, this becomes a lot harder than it should be. So let's follow our workflow. We're going to create a new setup on this back side. And then we are going to create a new feature. And then we'll run that feature through the database, and it's going to create an area clearance. This is a 3-axis roughing and a constant step over. Now, I need to constrain these features. So we're going to add what's called a contain area, and I'm going to contain it to this face. So I'm just picking a face. This is a benefit of being in a good CAD tool. And we're going to take that contain area and copy it down to the finish pass as well. Let's generate some toolpath for this finish pass. I haven't adjusted any step over or depths of cut or anything, so we'll take a look and see what it gives us. Okay, so we can see it's sort of dipping down into the logo. And if we adjust the step over here, this is considered a constant step over, 3-axis toolpath. It's intended to create an equal scallop in all directions. So if I adjust my cut amount, just cut it in half here. Okay. So we can see it's dipping in to the pocket. I don't want it to do that. So the best way we can get around this is we can cap this surface. So I'm going to go to my SOLIDWORKS tools. I'm going to create what's called a filled surface. And I'm just going to use these edges. Around the model. To create a continuous surface. And I can make sure that that surface is keeping a tangent on all the boundaries. And look what happened. I got a pop-up, and CAMWorks is warning me that the toolpath has to be updated. It recognizes that the solid model has changed. It immediately prompts the user to update the toolpaths, and it's going to go ahead and do that for me. It's going to recalculate, and what we're going to see here is that on that side, it follows the smoothness of the dome. Once I have that toolpath in place, I can hide that surface. And my toolpath will remain. And that would allow me then to create maybe a second constant step over that has a different contain area. Contain just to that area. So having access to really robust surfacing tools helped in this case. Of course, we can access different sketch tools. Also, as a function of SOLIDWORKS, we have access to assemblies. So if I am cutting more than one of these parts, I might take the time to pull them into an assembly with all my fixturing. This is a core function of SOLIDWORKS. They've been doing this for over 20 years, and they're the best at it in terms of creating mates that are intelligent, allowing us to build templates that have our Kurt Weiss and the Mighty Bite clamps in there, and being very able to very quickly place parts in here and mate them up. If we want to go more complex, we could throw these on a tombstone. Now, one of the benefits in terms of programming in this environment is that we can program a part in part mode and then simply import the CAM data from the part file. So we don't have to pre-program it here in the assembly. If we have more complex setups, then we can very easily create the setup, import the CAM data, sort the tools in the order that we want to reduce the amount of indexing that we're doing. And it's all just very approachable and easy to use. Now, I talked a little bit about the workflow, and we walked through a very simplified version of it, but I want to show you guys the real power of it. Here's a part file I pulled off GrabCAD. It's a fairly large adapter plate for an LS7 motor. Okay, it has a ton of features on both sides. And all I'm going to do is I'm going to ask the software, look at the model and identify machinable features. Tell me where the holes are, the pockets are. Tell me what the shape of the perimeter is. Choose a strategy for me. If it has toleranced dimensions, it will choose a strategy based on the tolerance window. If it doesn't have tolerance dimensions, it will choose whatever the default strategy is. So this is going to take a minute because there's dozens of features here. But as this is working, I'm chatting with you guys, right? I'm not going through the monotonous clicks of picking a tool, telling it where to go, customizing the CAM data, and now moving an inch over and doing it the same thing for the next pocket and the next pocket and the next pocket. All right. So as it's looking for the features, I'm starting to think about, order of operations, how I'm going to hold this. Programming is very difficult in that there's a lot of different details to keep track of. That's the most difficult thing about programming in my mind. And what CAMWorks and SOLIDWORKS CAM are set up to do is to take some of those details off your plate. Anything that's data-driven, it can automate. And it can do it in a way that will really effectively shave, hours off of programming a part like this. So, yeah, this has taken a minute or two. But I'm going to let you chug it. I knew this was going to take a minute, but I really wanted you guys to see in real time how long this takes and how many features it finds. And keep in mind that for every one feature it finds, it will often create 2 or 3 different operations. So now over here on the left, we have our setups. We have 2 setups, one for each side. And we have easily, I'd say that's 100 features easily. Now, my default strategy was set up as a rough rest finish. So it's basically a 2-pass rough cycle. I don't want that. But I also don't want to change the default. I can very quickly change strategies for, look at, in this case, it's 81 pockets all at the same time. I'm going to choose to do a rough finish on those 81 pockets. And also on these circular pockets and the rectangular pockets as well. So I just changed 91 pockets. Now for all of these features, let's run them through the database. This won't take as long. When I run it through the database, these features are going into an area where it's analyzing the parameters of the feature. It's looking at the type, the shape, the depth, the overall size, the material we're cutting from, the type of machine we're on, and it's making some suggestions on how we might want to cut that. What you guys are viewing here is sort of an out-of-the-box experience. But as we use SOLIDWORKS CAM or CAMWorks, and as we save our work back to the database, as I showed you, what comes out of that step becomes closer and closer to what you're after. But now we have literally 100+ different operations that have toolpath on them. Now we have different strategies to make editing them easier. We can combine them, we can link them. There's some tools that make sorting through this much easier. But imagine all of the work that we just saved ourselves from doing. It's monotonous work. It's all data driven. There's no reason for us to be doing it the old way. So I promised a quick look into the TechDB. We have more info on this available on our YouTube page, but I want to really quickly show you what it was doing. So we were in a mill. We were running features through the database, and we ran a lot of, say, irregular pockets. So if I look at all the irregular pockets, I have different strategies available to me. Now, if it's an irregular pocket and the rough rest finish strategy selected, these are the 6 different entries it can fall under. Is the feature a blind feature or a through feature? Does it have a bottom radius on the pocket or not? Is it on the main spindle or sub spindle? When it finds a matching entry, it comes down to this area and it tells it to create a rough mill, a second rough mill, and then a finish mill. And it's choosing the tool based on parameters of the feature. It's saying, what's the largest tool I can fit in there? Multiply it by 0.2, and then multiply it by 0.4. That gives you an upper and a lower bound. Go to my tool crib and choose a flat end mill that has a diameter between those 2 values. So my tool is guaranteed to fit inside the pocket. And then it's cutting to the feature depth plus no more. When we look at the contour mill, which is a finish pass, that tool is being selected by the finish radius. That's the tightest radius in the walls of the pockets. So it's choosing a tool for me from my tool crib based on aspects of the feature. This is awesome. And this is totally customizable. If I know exactly what tool I want, great, I can choose that. But let's say I want to customize the depth of cut, or the feeds and speeds, or I want to automatically tell it to slow down in the corners. I can do that, and I can do it one of 2 ways. I can do it here in the database, which will help for future use, or I can simply just program my part and save my work back to the database. And that's a great way to build a very robust database. If you're programming for multiple machines, you might need to do different things. If you have a laser next to a mill, next to a horizontal machining center, all of those are probably going to cut parts differently. And SOLIDWORKS CAM and CAMWorks gives you the ability to set up these smart templates per machine. So I hope you guys like what you saw in this little presentation here. It's meant to give you just a little bit of a glimpse behind what a good feature-based CAM tool looks like, what the opportunity is there for just time savings and more accurate programming, and also just what the user experience might be for being able to hop back and forth between the CAD tool and the CAM tool and have the best of both worlds all in one package. So I want to thank you guys for joining. This was a fun little webinar to put together, a little bit different for us, a little bit less detailed than what we normally do. Like I said, this is going up on our YouTube page, and we already have dozens of other videos up on YouTube. If you want to learn more about what we talked about, then go ahead and check out our YouTube page, just youtube.com/GoEngineer. And also, if you have any questions about what you saw and you want to ask them, shoot me an email. I'd love to answer them for you guys. So thank you for joining. I appreciate your time, and I'll catch you later.